How do airplanes fly? I'm sure most of us have traveled by flight multiple times in our lives. But have we ever questioned how are we in the air? How is the aircraft defying gravity? To answer this question, we must look at the structure of the aircraft, which will then explain how it generates a force that lifts it, and it will also explain how other external forces act on it. To understand the structure of the airplane, we must understand two different concepts in aerodynamics. Firstly, the relationship between pressure and air. A fact we all know is that air travels from areas of higher pressure to areas of lower pressure. Therefore, to deliberately make air move, you have to create differences in pressure. Now, when is pressure higher? Pressure is higher when there are more number of air molecules making more collisions. And obviously, when are air molecules going to make more collisions? When the space for the air molecules to move around is less. Essentially, when the volume is less. So, two factors which affect the air pressure are the number of air molecules, which it basically means the number of air collisions that the air molecules will make. And the second factor is that the volume that the air molecules have to move around. The second concept that we will see in aerodynamics is that will be important to explain how airplanes fly is the relationship between volume and air. Now, when air molecules are in motion and then we constrict them to a region of lesser volume, the velocity of the air molecules traveling increases. Now, to explain that, I will use a real life example. When using a garden hose, we put a finger on the cylindrical opening. And then what happens? The water rushes out much quicker. Why? Because we are decreasing the space that the water molecules have to escape the hose. Hence, we are decreasing the volume that the water molecules have to escape. And therefore, water rushes out much faster because we're squeezing it through an area of lesser volume. We're squeezing it and we're forcing it through an area where it does not have enough space. Now let's look at another case. When these air molecules in a bottle are being forced through the narrow gap, the neck, they gain velocity and move much faster than the neck of the bottle when compared to the part before. The particles of air at the neck are accelerating, and when they are accelerated, you can see that they're more rarefied. They have space between them. So the collisions between the air molecules decrease. And if the collisions between the air molecules decrease, then it creates a low pressure zone at the neck of the bottle. And what happens when we have differences in pressure? The air flows from the region of higher pressure to the region of low pressure. So that higher pressure region is where the bottle is, and the low pressure region is where the neck is. So the air flows from the bottle to the neck and out. So when the air molecules are forced through or squeezed through something, they gain velocity, like the water coming out of the hose or the molecules that are being squeezed through the neck of the bottle. And we will see why this concept will matter later in this video. Now, moving ahead with these two aerodynamic concepts in mind, we will see the four forces acting on bodies that are in motion in fluids. Let's consider our body in motion to be our aeroplane that is in motion in air, which is obviously a fluid. So the four forces acting on an aeroplane are firstly, thrust, which is generated by the engines of the aircraft pushing the plane forward. Secondly, drag, which is a resistive force caused by air friction acting opposite to thrust. Thirdly, lift, which is what we will mainly look at in this video. It is a force that allows the plane to fly. And fourthly, downforce, which is another resistive force acting opposite to lift. Now, the force that helps an aeroplane to gain flight, as mentioned before, is lift. Lift is basically the force that pushes the airplane upward. So it is imperative that the aircraft is designed in a way that it generates lift. We will not cover the other three forces in this video, but they are equally important as they have a great impact in the design of the aircraft. Now, how is lift generated and how does it impact the design of the airplane? The primary way is in the form of wings. To understand what wings are, we must know what airfoils are. Airfoils are structures that produce lift or drag when moved through the air, and the airfoil that is most commonly used is a wing. Now, the shape and design of the wing is responsible for generating the lift for the aircraft. The cross section of a wing looks something like this. Okay, so now how does this design of the wing generate lift? Now let's imagine this. This wing is moving through the air. The air will make contact with the wing and the wing will separate the airflow. But how will the wing separate the column of air that it's making contact with? The answer to that question is essentially answering how lift is generated. Wings are designed in such a way that they have unequally separate the air that flows and towards it that make contact with the wing, and they unequally separated above the wing and below it. So they deviated unequally above the wing and they deviated unequally below the wing. So now, when the air column hits the wing, let's first see what happens to the air that is deviated under the wing. As you can see, the air gets pushed down by the wing in a pretty straightforward manner, as the air flows along the shape of the wing. But the top of the wing does not have a smooth curve like the bottom of the wing. The top of the wing has a more aggressive, sharp curve. And now let's see how air is deviated at the top of the wing. Now, as you see, at the top of the wing, the air has to take a more aggressive approach around the shape of the wing. And it is deviated at a much, much greater angle than the air column at the bottom. This means that at the top of the wing, the air that is flowing is being squeezed between two things. Firstly, the top of the wing, and secondly, the air column of air that is undeviated, that is flowing horizontally. So the air is being squeezed to flow between the two red arrows. And from what we've learned before, when the air is squeezed through something, it moves much, much faster. So after making contact with the wing, the air that is deviated upwards moves much faster. And when the air moves faster, the airflow is rarefied, creating low pressure above the wing. And what do we know about differences in pressure? Air moves from regions of higher pressure to regions of low pressure. So the air moves upwards, thereby pushing the wing upwards. And why is there higher pressure at the bottom of the wing? Because obviously, when we compare it to the top of the wing, the pressure is obviously higher because at the top of the wing, the pressure is lower because of the airflow being rarefied, because the airflow is being squeezed between the horizontal column of air and the top of the wing. Hence, with higher pressure and low pressure, the air pushes the wing upwards. Hence, a force is generated by the air pushing the wing upwards, and that very force is called lift. This lift pushes the wing upwards, essentially pushing the entire aircraft up, allowing it to fly and soar the skies. Another way that lift is generated, in the same way, is that if we look at the overall deviation of the weight of the air after it hits the wing, clearly, as you can see, it is downwards. So the air is being pushed downwards by the wind. And to that, we get a reaction force. And the reaction force is upwards. How do we get that? Through Newton's third law of motion, which states that every action has an equal and opposite reaction. So the action is the air pushing the wing downwards. And the reaction is the reaction to that is the air being pushing the wing being pushed upwards. So, therefore, through differences in pressure, along with the reaction force on the wing, that generates lift. This lift also pushes the wing of the aircraft upwards, which pushes the entire aircraft up, which basically enables it to fly. And that is why the design of the airplane generating lift is so important. There are also certain other ways in which we can increase the lift force produced. Firstly, by increasing the speed of the aircraft, which is done by the engines, which generate thrust, one of the four forces we mentioned before. So if the thrust generated is higher, if the velocity of the aircraft is higher, the lift generated is more. Therefore, the aircraft can fly higher. This is why fighter jets, which travel at insanely high speeds, can perform maneuvers that passenger jets cannot, because these fighter jets have much more powerful engines, so they generate much more thrust. Another way which we can increase the lift is by changing the angle of the wing. Because the more aggressive the angle is at the top of the wing, the more the angle of the deviation of the air is, and the more the air is going to be squeezed. So the more the difference in pressure, and hence the more the lift that is going to be generated. Now, we have certain devices on the airplane that can help increase the lift generated in two ways that we've mentioned above. Firstly, we have flaps. Now, how do flaps work? Flaps are devices on the wing that get activated when the plane is taking off or when it is landing. When taking off, these flaps extend, therefore increasing the angle, separating the air even further, creating a greater difference in pressure, and therefore generating more lift. This extra lift that is generated helps the plane while taking off. So flaps essentially change the angle of the wing. Now, the other factor. How do wings manage to generate so much lift that it can lift the entire airplane, which on an average weighs 200 tons? As we saw before, to increase the lift generated, the velocity of the plane has to be increased. And this is the job of jet engines, which generate thrust. This thrust that is generated enables the plane to reach velocities of 800 kilometers per hour in flight, thereby generating the lift required to fly 60,000 feet in the air. Therefore, by generating lift with the help of wings, flaps, and engines, aeroplanes can soar the skies. Thank you.